This is Geometry Unit 6, Lesson 8, Angle, Angle, Side. Now, we have three ways we've already proved triangles congruent. We have side, angle, angle, and side, side, side. Our fourth way is using one of the previous ways to prove angle, angle, side. Now, notice I said angle, angle, side. Notice the side is not between the angles. Now, let's see why this works. So, if we have these two triangles where angle A is congruent to angle D, angle B is congruent to angle E, and BC is congruent to EF. That would be angle, angle, side. All right, now why does angle, angle, side work? Well, let's think about angles C and F for a second. If we know that A is equal to D and B is equal to E, that's going to force C and F to be congruent. So for example, say angle A was 40 degrees, and that means angle D would be 40 degrees. Say angle B was, say, 60 degrees, then angle E would be 60 degrees. Now, how many degrees does that leave for angle C and angle F? Well, 40 and 60 is 100. That means this has got to be 80 degrees, and this would have to be 80 degrees. So, the two angles being congruent forces the third angles to be congruent. The two angles congruent forces the third angles to be congruent. So that means the triangles are actually congruent by angle, side, angle, angle, side, angle. So as a shortcut, if we can get angle, angle, side to save ourselves some time, you can use angle, angle, side instead of angle, side, angle because it forces the third angles to be congruent. So angle, angle, side says if two angles and a non-included side, now that's important, the side is not between the angles, are congruent to the corresponding angles inside of a second triangle, then the triangles are congruent. So you need to tell the difference between angle, angle, side and angle, side, angle. So let's take a look at angle, side, angle, 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 side. All right, so let's look at this triangle. We have ABC and DEF. Why are these two triangles congruent? Let's look at the congruent parts. We have angle, angle, A is congruent to D, and then we have C is congruent to F, and then we have AC is congruent to DF. Now, where is the side in comparison to the angles? It's between the angles. So these are congruent by angle, side, angle. The side is between the angles. On this one, we have A is congruent to D. We have C is congruent to F. But on this one, BC is congruent to FE. So the side is not between the angles. So this one is actually angle, angle, side. But since A and C are congruent, that means that B and E are forced to be congruent. So unless we know something about B and E, this could also be angle, side, angle. But from what we have here, because of the way this theorem works, if we can get angle, angle, side, then the triangles are congruent. So let's see how we apply this in a proof. So in this given, we have pentagon TOPAZ, topaz, five-sided figure, with diagonals TP and ZP. Triangle TZP is isosceles with vertex P. Angle OTZ is congruent to angle TZA. O is congruent to angle OPA, and angle A is congruent to OPA. And we want to prove that OP and AP are congruent. So here's OP, and here's AP. So probably, if we want to get those two sides congruent, we probably have to get a pair of triangles congruent. So what triangles contain those sides? Well, that'd be the triangles in the end, triangle top and zap. So here's triangle top. Let me draw it here. And here's triangle zap that I'm going to draw exactly the same way, or pretend to. And I'm going to label them exactly the same way, T-O-P, T-O-P. And I'm trying to get them to be congruent, Z-A-P. So the sides I'm trying to get congruent are O-P and A-P, are the two sides I'm trying to get congruent. So let's prove the triangle's congruent. Go right to your given. We have pentagon, five-sided figure, topaz. We have diagonals, TP and ZP. And then we have triangle TZP is isosceles. So that's my first given. All right, I forgot, with vertex P. Okay, so if TZP, this triangle right here, is isosceles, what do we know immediately about isosceles triangles? Well, an isosceles triangle has two congruent sides. So if P is your vertex angle, TP and PZ are congruent, or TP is congruent to ZP. So that gives me an isosceles triangle has two congruent sides. So that we've just proved that this side and this side are congruent to the triangles that we want. So I've used that given. My next given is angle OTZ, which is this whole angle right here, is congruent to angle TZA. All right, so that's given. Angle OTZ is congruent to angle TZA. That's given. So let's look at the triangles we're trying to get. Do we need the whole angle OTZ? Well, OTZ is right here. That goes kind of like this past here. And the angle TZA is this angle right here. Again, we only need a little piece. So what we need to do is we need a smaller angle. So we need to get rid of these two pieces right here. But how are we going to do it? Well, we probably have to use subtraction, but that's only going to work if angle PTZ is congruent to PZT. Well, are they congruent? Well, remember, what was this again? This is an isosceles triangle. So what kind of angles are these two angles right here? They're base angles, and therefore they're congruent. So we can say angle PTZ is congruent to angle PZT, because base angles of an isosceles triangle are congruent. Base angles of an isosceles triangle are congruent. These two sides are congruent, so those two angles are congruent. Now can we subtract? Yes, we can. I can take step 3 and step 4. I'm going to take OTZ and subtract PTZ. If I take OTZ and subtract PTZ, I end up with OTP, which is this angle right here. And if I take TZA and subtract PZT, these two right here, I end up with angle AZP. And that's using subtraction on statements 3 and 4. I took this minus this, and got these two angles. So I now have these two angles right here are congruent. So I've used this given, used this given, and now we're down to our next given. We have angle O is congruent to angle OPA. This angle here is congruent to this angle here. Let me do it this way. This angle is congruent to that angle, and then angle A is also congruent to that angle. Well, can't we use substitution on that? They're both equal to OPA, so they're equal to each other. You could also say transitive, but that's given. So by substitution, these are both equal to OPA. So that means angle O is congruent to angle A by substitution. Or we can say transitive, either one would be fine. So we have now proved that this angle O is congruent to this angle A right there. So are the triangles now congruent? Based on what we've been doing, yes, this is angle, angle, side. So we can say triangle top, I'll do top, is congruent to triangle ZAP. TOP is congruent to ZAP, and that's using angle, angle, side. I proved two angles and the non-included side. Two angles, non-included side, so verify the triangles are congruent. And since those two triangles are congruent, all the corresponding parts are congruent. So that means side OP is congruent to side AP using CPCTC. So that is the fourth way of proving triangles congruent. We can now prove angle, angle, side, and triangles are congruent.